We are going to use scaffold ETH in order to solve the speedrun Ethereum challenges. We will go into them, and so basically are some really nice challenges that teach you both how some basics of the blockchain and the Web3 work, and at the same time you can get used to using scaffold ETH and so on. But before starting, I want to ask you, did you by any chance with Fabrizio do any like ERC standards like ERC20 and stuff like that? Any token standards? No, I don't think so, no. So before talking about the also other two things, we will have a hard stop around 3:25 ish, because I have a call. I cannot postpone it. And then from 5 p.m. to 6 p.m. Limone will talk a little bit about hackathons and how they work and stuff, so that you can get ready for tomorrow. So we will stop at 5 basically. So before starting talking about the speedrun Ethereum challenges, I need to talk about the standards. So in the Ethereum community, there are different standards, and basically a standard is a way that we can define something that can be, for example, reused by many developers, or also in the case of Ethereum, also in guidelines or communication, but we'll focus on the technical implementations. And why do we need standards? Because of course, if in a blockchain environment, if everybody was to develop their own stuff, it would get basically a mess. So everybody would have their own smart contracts working in their way, and it's actually like this. But thankfully, there are some standards that are pretty used, and so we're going to focus on two of them, which are called token standards. Yeah, it's actually like an RFC, but in Ethereum are called ERC, which stands for Ethereum Request for Comments, basically. So it's like an RFC, but for Ethereum. And in this case, we are going to focus on two token standards, so which are the ERC20 and the ERC721. And basically, these standards are just interfaces. So from a code point of view, it's like basically defining how this smart contract would work, what are their properties, their functions, the return value of the functions, and so on and so forth. And the most important one, and the one that it's actively, I think, the most deployed smart contract on any chain, on any EVM chain, is the ERC20 token standard, which basically defines fungible tokens. Fungible meaning when something is fungible, it means that one item, like two items of the same category, basically are interchangeable. So you can think something fungible like dollars or euro. For example, if you have €1 and €1, they are completely interchangeable. So the ERC20 token standard is used to represent any type of fungible asset, whether it could represent money, whether it could represent, for example, as you can see over here, reputation points, as we said, fiat currency like USD, skills of a character in a game, and so on and so forth. So why this standard is so important? It's because, as you may imagine, even if it seems fun to make it represent skills of a character and so on and so forth, it's mainly used to represent currencies on chain. So this is the standard that it's used to basically define all the coins that you may have heard of, and like Pepe or whatever, any kind of meme coin as well. They are all basically ERC20 tokens. And as I said before, ERC20 is just a standard. Then how you define the functions of, how you define the body of the function, of course, it's up to you. But of course, it's always better to keep pretty much everything as it's meant to be. So the ERC20 standard, which I will show you from a contract point of view, and I will send it to Discord so that you can check along on your computer, because I think that you will see it better. Right here, I send you the GitHub page of the ERC20 contract, and just want to show you what this contract does. So we're going to read this contract together and to understand basically how it works and why it's basically used as a currency in this case. So we have some private variables such as the balances, which basically it's a mapping. I think you saw mappings with Fabrizio, and basically this mapping tells the smart contract for each account how many tokens does this account hold, basically. Then we have the allowances that we will talk about later when we will see the function, but it's a mapping of a mapping, but as said, we are going to see it later. Then we have the total supply. So basically the total supply, it's the amount of supply of these tokens that it's available. So it can be 10,000, 1 billion, whatever you want. And also it can vary as well. So it does not need to be fixed. So as you can see in this contract over here, well, this is an abstract contract, but for example, you can create an ERC20 token that you can create also, like, you do not need to define it at the start, but you can increment the total supply when you want to create this token. And this operation, it's called minting. So it's a mint operation. And usually in smart contracts, in ERC20 tokens, where you mint something, so when you create new coins, you also have the burn functionality, which means to basically destroy. So it's decreasing the supply. So the mint is going to increase it and the burn is going to decrease it. But this smart contract here does not have the minting and the burning functionalities. Also, something which is really cool about your question?
So in the ERC20 contract is defined like every individual token, like Dogecoin, for example, that's still in ERC20?
Bitcoin, sorry?
Dogecoin?
Yeah, Dogecoin, it's well, Dogecoin has its own chain, I think, but you get the point. Like, if you add, for example, I don't know, Shiba for it, it's an ERC20. And the name and the symbol, it's actually what we're talking now. So the name, it's the name of the ERC20 token that you're creating, and the symbol is the ticker. So if we go to any, I don't know, this one, which is pretty funny, which is called KeyCat. This is not financial advice, by the way. So just to be, so for example, this one is called KeyboardCat, and KeyCat, so this is the name and this is the symbol, and well, this is an image of a cat typing on a keyboard. So this is the name and this is the symbol, and the symbol is the one used pretty much to show it as a ticker, like USD. It's the ticker for dollars. KeyCat is the symbol of this token. So getting back to the contract, it's pretty easy. Like when you create, in this case, a new ERC20, you pass a name and a symbol, and this is what we were seeing before. These functions are read functions to get the name and the symbol and whatever. And then we have the concept of decimals. So I think that I think I saw a message that Fabrizio sent you, which should be this one here, decimals in Solidity. So decimals are pretty important when working on Solidity, and also they are really important when dealing with ERC20s, because as you may know, in Solidity there's no like floating point, and for example 5.05 does not exist in Solidity, but it's actually 505 divided by this amount. So this is why we have decimals, and decimals are really important when you build front ends, because whenever you read or send amounts to the blockchain inside a transaction, you are always going to send them at the correct decimals. So in this case, this function, this ERC20 has 18 decimals, which is the standard, but actually there are some ERC20 tokens that have 6 decimals or 9 decimals. So whenever you need to manage these tokens in your front end, or when you need to call the functions, you always need to first retrieve the amount of decimals that that given token has. And this is really important, because if you do not manage the decimals, you may end up, for example, dividing a token that has 6 decimals with one that has 18, and the result will not be the one that you are expecting, because it's not the same number actually when you send it to the blockchain.
So one example, maybe if I have 3 decimals, one token, how many is it?
One token with 3 decimals is one with 3 zeros, basically. It's one with 3 zeros, yeah. And so at the same time, if you have 18, it's one with 18 zeros, basically. And so even if one is one, actually when you are going to send it, or when you're going to deal with them, you need to send one with 18 zeros and one with 3 zeros, and not just one, because one means basically zero, like all the zeros and then one, so it's basically the smallest amount that you could send. So, well, this is another read function for the total supply. This is a function that allows you to retrieve the balance of a given address, and we are going to use these functions later while using scaffolded. And then we have the transfer function. The transfer function allows the caller of the function, the message sender, which in this case it's not the same message sender that you saw before, because in what you saw with Fabrizio, you use this message.sender, while instead in, where is it? In the ERC20, they are using this function, which comes from another contract, which is called context, but we will not go into that. But basically, this message sender is used to always get the one that is submitting the transaction, because there are some cases where the message sender could be modified and so on, so it's just a security feature, so you do not need to really worry about it. In our case, when it's a user interacting with it, it's always it's like putting message.sender basically. And the transfer function is going to call this helper function, which is the underscore transfer, and the underscore transfer function, it's pretty easy, so it just checks that the from and the to addresses, so who's sending and who's receiving, are not the empty, like the void address. And yeah, I will go back to it later. And then it's going to basically, so now I am going to explain it. So basically, so the transfer cannot be done to, like the transfer cannot be done from or via the address 0. But when before I was talking about minting and burning, actually when you mint an ERC20, it's like the sender of the transaction of mint, said it like this is wrong. So when you mint an ERC20, it's like it comes from the address 0, and when you burn an ERC20, you send it to the address 0. And let me see. Okay, so we have the burn and mint, so we're going to see it now. So this is the mint, and this is the burn, okay? If we go into the update function, which is the one that it's used both in the transfer, in the burn, and in the mint, what this function does, so if the from is the address 0, which I just told you, when the from is the address 0, we are minting. What we are doing is we are increasing the total supply. So we are creating new tokens, basically. So if we had 0 and we are going to mint 10 tokens, we are going to have a total supply of 10. In the case it's not the from, in case it's not the address 0, so we are not minting, what we are doing is that we are retrieving the balance of who's sending the token. We are checking that with this check that who's sending the token has enough balance, of course. So in the case I try to send 10 tokens, but I have 5, it's going to revert with this ERC20 insufficient balance error. And then it's going to basically decrease my balance. Okay, so balance of from, in this case I'm the one sending, gets decreased by the value that I'm trying to send. After my balance has been decreased, and this is really important from a security point of view, sadly we do not have a lot of time to talk about security of smart contract, but you always need to decrease this before updating the other, and I will tell you in 10 seconds, but after I decrease my balance, there's another check that says, okay, if I'm sending to the address 0, I'm burning the token. So I just decrease basically the total supply. So if I'm transferring these tokens, which is not from using the transfer function, but using the burn function, if I'm transferring these tokens to the address 0, I just decrease the total supply. So if I burn 10 tokens that I just minted, basically the total supply goes back to 0 and my balance has been decreased. Instead, if I'm sending it to an address which is not the address 0, his balance is going to be increased. Why I was telling you that this always needs to happen before this is because there's a security attack that can be done on smart contracts, which is called reentrancy attack, which is basically when you call multiple times these kind of functions, and in the case this would have been placed after this one, whenever I would enter this function, basically I could increase infinitely my balance. So that's why before I need to decrease mine, and then I need to update the other. And whatever. And this emits an event here. The unchecked thing there. So the unchecked is it's basically in this case it's used to optimize a little bit the gas, because when you perform these kind of mathematical operations, basically by using the unchecked, you are able to spend less gas performing these operations, but it's just, there are some Solidity developers that are really concerned about even saving 10 units of gas. So, but in reality, the unchecked, it's used when you need to perform some bitwise operations, so it's used in more complex environments, but it's really advanced Solidity, and most of the time it's never used. In this case, it's mainly used to save some gas on these operations, basically. So it's unchecked because, as it says here, there's no possibility for overflow, and so I do not need to check for some operational security features that Solidity has, because as it says over here, the value, it's always lesser or equal than the total supply, and the value and the from balance, it's always in this range. So there's no need to have underflow or overflow checks. So that's why it's unchecked, basically. And yeah, those are the mint and the burn. And then we come to what I think it's one of the most important functions, and also one of the most overlooked ones, which is the approve. So the approve function, which is this one, of course it checks always that the owner and the spender in this case must not be the address 0. The approve function increases the allowances mapping of the owner and the spender of the amount of value. What does it mean? When I approve a spender of a given amount, basically I allow that address or that smart contract to move funds on my behalf. So basically, by approving a smart contract, that given smart contract can take away ERC20 tokens from me and move them, okay? So that's the goal of the approve. So I say, I want to approve Limone, in this case, of 10 USDC spending. Later, Limone can pull these tokens from me and use them for whatever. So, yeah. What, sorry? No, Limone needs to be a smart contract for sure, so it cannot be done from EOAs, but it's just a matter of allowing smart contracts to pull tokens from you. Because now I'm going to talk about why this is important and what's the difference between ERC20s and ETH. So we I skipped a function before. I don't know if you know this, but we have the transfer function, which is the one that I'm the one sending, which is the message sender, as you can see over here. But then we have also the transfer from function, where you can define an address from the one you are basically transferring this token. So this is the function which is pulling these tokens and sending it elsewhere. So in the case of Limone, if Limone was a smart contract, after I give approve to Limone, the smart contract can then call the transfer from and use my tokens and transfer them elsewhere. Maybe he wants to transfer them to himself or to another smart contract or do whatever. And why this is different from, and why this is important and why this is different and why I'm talking about this, because you have done these payments over here, okay? So, no, this one has the receive, which was this one, I think, that I saw. Yeah, whatever, let's use this one. So, the main difference between sending ERC20s and sending ETH is that when you interact with a smart contract, when you send ETH, you can send ETH alongside the call of the function, okay? So you can basically call a given function, which is marked as payable, and you can send ETH in the same transaction and getting it with the message.value. I don't know if you have it. I remember I saw it somewhere, but don't know if you have done this stuff. But basically, as you have the message.sender, you also have the message.value. The message.value as the amount of ETH that was sent inside that given transaction. But this cannot be done with ERC20s, okay? You cannot send ERC20s to a smart, like you cannot call a smart contract function and send ERC20s alongside with it, okay? So how do we fix this thing? So how can I send ERC20s to a smart contract? Maybe I want to buy, I want to participate in an auction, for example. I want to buy this NFT, which is something that we will see later. I want to buy this NFT and I need to pay with the USDC token, which is a stable coin, which one USDC, it's $1. I need to pay 1,000 USDC to buy this NFT. I need to call this function, but I cannot send the tokens. And that's where the approve function comes in. So basically, when using ERC20s, the flow is that I approve the contract that I'm about to call to take 1,000 USDC from me, and then I'm going to call the function, I don't know, make bid, whatever, bid or buy. Let's call it buy NFT. I'm going to call the buy NFT function, and the buy NFT function is going to call the transfer from, and it's going to pull these ERC20 tokens from me. So that's why we have the approval and the transfer from. Yeah.
I find it quite annoying thing about why is it not? Why
because the ERC20 token, it's a really old token. So it's a really old standard that was, it's like ERC and then the number, it's an incremental number. So you can imagine if ERC1 was the first ERC that proposed how all the future ERC would come, the ERC20, it's just 20 ERCs after. And between the ERC20 and the ERC721, there's a lot of time that has passed. In fact, this is not the case with ERC721. And it's just a matter of how old the ERC20 token is and the fact that since it has been used in so many ways and it has become so the standard basically to do coins on chain, of course, we are stuck with this problem. There's a standard that they proposed in reality, which I don't remember if it's here, but it's a standard that they tried to do, which is the ERC777, this one. The problem with this one is that, as you can read in this huge warning, as is really susceptible to a lot of different attacks. So basically, they try to extend the ERC20 functionality and use the hooks, which is the functionality that the ERC71 has, which is basically allows any smart contract to react when it receives ERC721 tokens. They tried to put it inside the ERC70, inside this ERC, but it went like nuts. So they told it could create a lot of problems, and as you can see, this one requires a double call. Instead, this one uses the hook, but it didn't go well, if you want my opinion. So we are basically stuck with this double transaction forever. Yeah, it could be done, and we are going to see how it's done on the ERC721. So I wanted to tell you this stuff about the approve and the transfer, because it's something that you will find a lot, like whenever, like either in the hackathon or also if you want to keep on working on in the Web3, this flow of ERC20, so the approve and transfer from, it's used everywhere. And any front end, whenever the user needs to spend its ERC20s, it always needs to let the user approve the spending first. Something that you may ask is that the easiest solution for this is that, okay, I just approve the smart contract to spend any amount of tokens, so that I do not need every time to, no, sorry, because I didn't tell you how the transfer from works. So after the transfer from has been called, my allowance, so it's not mine, but Limone allowance in my behalf, basically, decreases of the amount that is going to transfer. So why don't we have a whiteboard? So if I approve Limone to spend 10 tokens, Limone transfers 5 of my tokens, the allowance of Limone is 5 in this case, because he just transferred 5. So every time decreases, of course, it cannot go below 0, and he can only spend maximum the amount. So what does that mean is that after Limone has spent 10 of my USDC, I need to give him the approved back, okay? Because he basically exhausted the amount of tokens that he can transfer. And you may ask, okay, why don't basically I approve Limone to spend the total supply of the token? Who cares? So Limone can every time basically transfer my tokens without me needing to approving and so on and so forth. And that is something that a lot of developers have done in the past. And actually, as of today, it's one of the ways that people scam others on the Web3, because basically by allowing, basically people developing front ends propose these transactions to the users, telling them, okay, just give me the approval of all the tokens possible. So in the case in the future you're going to buy some or you're going to get some, I will be able to get them away from you. So it's actually used mainly for scamming, this kind of functionality. So it's always to let the user approve the amount of tokens that he needs. That's for security reasons. So if I need to spend 1,000 USDC, there's no need to let them approve 1 million. Okay, even if I have 1 million, for security reason, always approve the amount that the user needs to transfer, even if that means every time performing 2 transactions. So that was the ERC20, basically. So it's a really simple smart contract, even if it may seem long, it's just mainly comments. And the second token that I wanted to talk about is the ERC721, which came in 2017, 2018. And basically, as the ERC20 token is a token that defines fungible assets, the ERC721 it's a token that describes non-fungible assets. So assets that are not interchangeable between each other. So in this case, you can see some examples. You could have collectible items. You could have numbered seats for concerts or sport events. You could have anything that you can identify as unique, basically. So I don't know, unique cards and stuff like that. So the ERC71 is actually, of course, more complex than the ERC20. And here there are some popular NFTs that maybe you have heard of, for example, the Bored Apes that have gone really wild some years ago, about, I don't know, costing millions. And CryptoKitties, that was one of the first. Actually, it's not an ERC21, it's not an ERC721, but has some functionalities. And this is really, really old. This is like 2017, and it was really nice. These little kitties, but whatever. Just some nostalgia, sorry. And so, the ERC721, as you can see, it's way, way, way more complex than the ERC20. This is because it needs to describe non-fungible assets. So there's a concept of uniqueness, and that's why we have the concept of token ID. So each NFT, each token of each ERC71 token has its own ID, so it's unique, basically. And you still have the name, the symbol, you have the owners, the balances, the approvals, the operator approvals, which is pretty much the same thing. So everything right here is pretty much the same. You have the constructor with the name and the symbol. And this comes from another ERC. Don't worry about it. It's basically to check that this smart contract actually supports actually supports the ERC721 and the ERC71 metadata that we are going to talk about it. Also has the balance of, but as you can see, it has a concept of owner. So each token ID has its own owner. So that's why I was telling you about, for example, the tickets to a concert, as when you go to the stadium, you have your name written on the token. Here you are basically the name written on the ticket. Here basically instead you are the owner of that given ticket in this case. You have the name, you have the symbol, and then we have the first main difference between the ERC20 and the ERC721, which is the token URI. So associated with any ERC721 token, you can associate metadata. So I'm going to show you metadata standard. So basically there's a standard for metadata which comes from OpenZeppelin, which is an NFT marketplace. And so sent you on Discord. Basically the token URI, which is, let me close the ERC20. So basically the token URI, it's a function that gets a token ID as input and then returns an URL. Limone, puoi chiudere la porta che non mi tocca strillare. This is going to return a resource, a unique resource identifier for that given token ID. What does that mean? That we can, for example, put an URL for that given token ID, and that URL must return a JSON containing different information. This is a pretty big standard, but you can have, for example, the image of the token. You can have the name, the description, the background color, the animation URL. So it's a standard that allows other clients and other websites to show your tokens, basically. So you can enrich your token with, as I said, animations, name, and also attributes. Attributes are basically traits that are connected to your token, and these are used mainly in NFTs, of course. For example, if we get a random NFT, I don't know, this one. I don't know what is this stuff, but whatever. Hopefully it has some traits. Of course, I took the one that has one trait. So let me get these ones. So in the case of NFTs, as you can see, all this data over here, so this image, the description, the traits, and so on and so forth, it's taken directly from the metadata standard. So you can, with this ERC 721 metadata, you can create more complex tokens, and also you can add any kind of information that you want, because you have this standard, but you can also extend the standard to add everything that you need. So in the case of a sports ticket, okay, inside your metadata you could put, I don't know, the number of the row in the stadium, the number of your seat in that given row, the entrance, and so on and so forth. So you can enrich basically your token, which in reality on chain, it's just an ID. So everything else that you see over here in like, do not look at the price, of course, but the image and everything actually does not live on chain. So it's outside, basically.
It's possible to see the JSON of this.
Yeah, I think that we can get it, hopefully, from, if we can get it somewhere. Otherwise, we can do.
So there's something basically that this JSON is stored somewhere, and if this somewhere centralized, they change
Yeah.
the JSON. And
Yeah, 100%. Yeah, this is really important what he just said. So basically, this token URI can be. Let me get this one.
It's not even hashed. I mean, if you would store the hash of the JSON, and it would be safe that nobody changes it, but nothing.
As you can see, does it look decentralized to you? It's not.
I think if you would put a hash, it would be fine.
Yeah. You can use some. You can use EPFS. You can use ETHRome, which are basically decentralized storages where the data is immutable. So, but which they are really interesting, but we do not have time to talk about them, and they are actually actively used by a lot of NFTs or ERC 721 projects. But in some of them are just basically using their own servers and their own APIs. In this case, it's the Bored, Ape, Club, and blah, blah, blah. And this is basically the JSON. And as you can see, the image of this JSON, in this case, it's stored on EPFS. But these are the attributes, which is background, M1 blue. If we go here back to the traits, as you can see, background, M1 blue. The far, it's M1 brown. I don't know whatever that means. But so let's talk a little bit about EPFS since we mentioned. So EPFS, it's a really cool open source project, which EPFS stands for Interplanetary File System. And I'm going to show you oh my God, EPFS just died. Whatever, so basically EPFS, it's a network of nodes that store data. Actually, they do not store full, like when you upload something on EPFS via a node, your data gets basically chunked and then gets shared among a lot of nodes, so it's also redundant, so that it's not lost. But the coolest thing about EPFS is that this value that you see here it's actually an hash, and it's an hash of the content that you just uploaded. What does that mean? Is that if I upload an image of myself, for example, on EPFS, I would get an hash. If someone else tries to upload my same image, he will get the same hash, okay? Because the image is the same. What does that mean is that if I try to change I cannot change the image, because that hash is going to always it's going to always target the same content, the same image. In the case of, for example, a JSON, if I upload a JSON on EPFS, and actually there was this one, which I think this is a website, but I'm going to talk to you a little bit about this as well. If I upload a JSON on EPFS and then I store immutably that given hash on an ERC 721 smart contract, and there's no way for me to change it, then since that image is always going to live on EPFS because I cannot remove it and it cannot be changed, then I have immutability also for my metadata. In this case, what they decided to do, it's a 50-50, where they basically uploaded an image on EPFS, but in reality, the API, it's managed by their own website, so it's not fully centralized. And what is cool is that if you go on, if you use epfs.io/epfs and then you put the hash, you get the image. So this is served pretty much for everyone, everywhere, it's always available, and this is really cool. And what I showed you here instead was, this is something that we built at an hackathon. Sadly, it goes too fast, but it's an hash that actually points to a website. In reality, it does not point to a website, but it points to an HTML page. This is something that we did with Limone in Brussels, because since you can basically upload anything on EPFS, you can also upload HTML pages, okay? So what we did is that we uploaded an HTML page on EPFS, and when the browser loads that given HTML page, inside the code of the HTML page, there's a redirect that redirects you to another website. It was not this one, it was this one. So it loads, and then it redirects.
And what is the pro?
What?
What is the advantages of this?
The advantage is that when yesterday I talked about something which is over here. I just said this stuff here. I said the term DApp, that stands for decentralized application, one time used to refer to unstoppable application. An unstoppable app, something which is served in a decentralized manner, is, in this case, an app, a website that it's available on EPFS. Okay, so if you upload the HTML, the CSS, and the JavaScript on EPFS, that website is never going to change and can never gonna be brought down, basically. So that's the point of uploading websites. This only works for something that can be compiled, of course, to HTML, JavaScript, and CSS. It does not work, for example, with Next.js, but with a basic React project, if you actively build it and get the HTML, CSS, and JavaScript, and you upload it on EPFS, it's going to be there forever. Nobody's going to basically put it down. And to give you an example, there's... Do you know Tornado Cache? Okay, so basically Tornado Cache, it's I need to find what's the gateway for Tornado Cache. Hopefully it's this one. So Tornado Cache was actually it's only banned in the USA, but it was an application that was used, which the goal of the application basically was to break the link between transfers of tokens, whether they are ETH or whether they are ERC20. So since the blockchain, everything is public, everything is transparent. If I want to send tokens to you, or I want to send my tokens or my ETH to another address, you can always see what I'm doing, where I'm moving my tokens, and so on. What they did with Tornado Cache basically is that you could send these tokens, and then later you could get back these tokens from another address without needing to share where you are sending them and from who you are getting them. So you can imagine that like Tornado Cache was used to basically wash a lot of money, okay? And it was mainly used by a lot of people that believed in privacy, of course, and so on. But of course, it was mainly used by North Korean hackers and like Taiwanese hackers as well to basically wash hacked money from hacks and stuff like that. So there was a huge lawsuit. Actually, the guy that developed Tornado Cache, even if they did not have any power on the protocol itself, was arrested, and that it's really sad actually, because he was arrested for basically coding, but whatever, he's still in trial. And So basically the cool thing about Tornado Cash is that even if the website it's locked in the US, since everything about Tornado Cash is decentralized, so the protocol is just some smart contracts on the blockchain, and since they uploaded the website on EPFS, you can still actively access. Yeah, because it's active on EPFS. I don't remember what is the. I think that it should be like Tornado Cash.
So to make a full
I don't remember.
application is to load the content on EPFS?
Yeah, that was what we thought a lot of, like more like 6 or 7 years ago. That was basically the goal of everything. Like we always had in mind this idea of having the backend to be the blockchain, and then the front end being something that you upload it on EPFS, and it's gonna stay there basically forever. Nobody's gonna change it, and so on and so forth. But the fact is that mainly from the front end point of view, a lot of stuff has changed. And in order to basically have websites to be more usable by people, to have more advanced features and even usability as well, because the fact is that EPFS seems cool and nice, you can upload your website, but it's actually really slow. It's painfully slow. Like the more the content is big, the slower it gets to be from being retrieved. And so also you cannot use, for example, some given APIs that you could use from Next. You cannot use caching. So the Web3 experience was really poor, and the whole community decided basically to abandon this idea of uploading websites on EPFS, even if it's really cool because it allows you to do this kind of stuff and creating these unstoppable websites. But today that has kind of lightened a little bit, but mainly due to the fact of, as I said, slowness and difficulty from people to use this stuff and so on. So let's get back to the ERC-71, and yeah, so getting back, we saw the Tokenuri, we saw the EPFS, which again, it's really cool, but sadly they're not getting any money, so I don't know if it's going to leave soon. Then we have the approve function, so it can work in the same way of the ERC20. It has the transfer from, it has also a safe transfer from function, which calls this function over here that I'm going to show you, which I don't think is actually here, but it's in another construct. So basically, the second main difference, so the first one is the concept of the third difference. The first difference is that ERC20s have token IDs. The second one is that ERC20s have a token URI associated to a given ID. And the third difference is that you can implement in your smart contract this interface, which is called the ERC-721 receiver. If you implement this function inside your smart contract, which is called the onRC-721 received, you can actually react to whenever an ERC-721 token is sent to you. How does this work? If we go back to the token on ERC-71 received, if you call this safe transfer from function, so whenever someone calls the safe transfer from function, as you can see, this is going to call this utils library, and it's going to call this method with that under the hood is going to call the onERC-71 received on your smart contract. This is really cool because I can send an ERC-721 or an NFT, let's call it NFT, it's shorter. So I can send an NFT to a given smart contract, and if that smart contract implements this function, it can do some stuff. you can also not only send the token, but what it's really cool is that, as you can see, when you transfer NFTs, you can also transfer data as well. This is really nice because in this case, and something that is done, for example, if I want to, like, let's imagine we want to develop an NFT marketplace smart contract, okay? The best way to do this is implementing this function over here and basically letting the user just send their NFTs to me alongside these bytes called data, which is unencoded. It can be an unencoded struct, an unencoded string, whatever you want. Mostly it's an encoded struct containing, for example, the amount of tokens that I expect to sell this NFT for, or when I want the auction to end, and so on and so forth. So you can send also data as well. And me, the NFT marketplace, when I receive this NFT, I can extract this data and perform any kind of operation that I want. So it's actually cheaper for the user, and it's also simpler for us from a smart contract developer point of view, because we just need to basically react to this kind of hook. And what it's cool at the same time is that if someone tries to send us any NFT without data, we can just basically revert the function and nothing happens. The token does not get transferred to us, and we can basically just stop. So that was the hook that they tried to implement also for ERC20s that went really bad. In this case, we can also, for example, bypass the approval by using this hook. So then there are not really other changes, not so much about those are the main three. We also have the same concept of minting and burning, but instead the minting in NFT smart contracts basically increment the token ID. So the token ID goes from 1 to 2 to 3 and so on, and also increases the total supply. While instead, the burning is setting the owner of a given token to the address 0, basically. So when you burn an NFT, you set the owner of that NFT to the address 0. And when you mint, instead, you create a new one and you give it the next token ID, basically. Yeah, so that was pretty much it about ERC20 and ERC721. Do you have any questions? Or
I didn't understand the part of approval and transfer.
Of ERC20s?
Yeah.
Yeah, let me get back the implementation, because I would like to a whiteboard online maybe. Can I like type stuff as well? Like amazing. So thank you. I didn't know that. I use it, but I didn't know that I could type. So the approval flow is basically, I don't know if I can zoom or if I can make it bigger, but so in the case of, wow, this is going to be painful without a mouse, but so in the case of ETH, it's actually called a push transfer. So, wow, this is really bad, but whatever. So when you send ETH, you are actually pushing ETH towards the smart contract. What does that mean? As I said before, when you call a function, you can send ETH alongside that given call, okay? So if I call, for example, a transfer function, let's call it 3TR. If I call the transfer function on a smart contract, I can also send ETH with it. The problem that we have with ERC20s instead, so let's say just E20, is that since we do not have that hook that I just showed you, I cannot perform a push, because if I try to send ERC20s to a smart contract, the smart contract is not going to react. There's no way for me to send tokens alongside the transfer function or the transfer or whatever function I'm trying to call. So that's the main difference between ETH and ERC20 tokens. So what they came up with, and this can only be done with ETH.
So Ethereum doesn't use ERC?
No, because ERC20s are something which is built on top of Ethereum. Ethereum and all EVM chains, there are some chains that allow you to do some stuff, but like most common chains, like also the most used ones, only allow their native token, in this case Ethereum, to be sent alongside transactions. Since ERC20 came later, and since it's not part of the protocol because it's just a token, it's just a smart contract built on top, you cannot send it alongside the transaction. So what they came up with is this logic over here. Whoops, so this is still the ERC20. My God, I'm really bad at drawing.
There's also a text function.
What?
There's also a text function.
Yeah, but it's faster typing. So we have so what they came up with is that now instead of doing this, let's use this one. Let's make it, I don't know, let's make it green. And in this case, this is me, and I'm the owner. Okay, I'm the owner of the tokens. Then let's make another one. Let's make it red, and this is the spender. And then let's make this thing over here maybe, and no, let's keep it this way. So the owner, it's me, and then we have the spender. So the spender is the one that, no, let's not call it spender, let's call it smart contract. So my goal is to send tokens to this smart contract, okay? Because I need to, as I said, purchase an NFT. Let's say that this is a NFT marketplace smart contract, okay? Inside this function, inside this smart contract, there's a function that allows me to buy an NFT for a given amount of tokens. The flow, since I cannot directly, this is harder than I thought. Since I cannot do, where's the arrowhead? Okay, so this I'm going to remove. Let's see, this is the buy function. As I was saying before, I cannot transfer I cannot send the ERC20s alongside the buy function call, okay? So what they came up with is, instead of the flow of money being from owner to, like me, actually pushing the token, so that's why it's called push. Instead of me actually pushing the tokens, what happens is that the first step is that I approve, for example, 1,000 USDC spending. Then when I call the buy function,
So I first call the approve function.
yeah, you always before call the approve function. When I call the buy, what happens is that the smart contract is going to pull tokens from me. So that's the main change. So this happens inside the buy call. So you need to imagine this as something that happens when you call the buy function. But I can show to you.
But this is done for security reason.
This is done because there's no other way for it to be done. It's the only way that you can basically send this kind of stuff because, as I was saying before, ERC20 being really old and there was no concept of hooks and other stuff, we are basically stuck with the first idea that came up to the guys that developed the ERC20, which is using this push. I can show you real fast, and then we will have a break in 5 minutes. I want to show you the code of this smart contract, why it needs to be so hard to find something. I'll show you real fast what I'm trying to tell you. Contracts. Oops. Should be contracts, pre-builds, marketplace, English auction, logic. As you can see, for example, this is a really complex smart contract that handles payouts, NFT marketplace, and so on and so forth. But as you can see, inside all of this logic, when I create an auction, in this case, what happens is that, okay, it's going to get the token type, blah, 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 it's going to create this struct, and then what happens is that it's going to call the, no, let's go to the payout, though, because I want to show you with ERC20s. So this function, basically, it gets called when I purchase an NFT from this smart contract, okay? Yeah, it's the payout. It's the function that takes care of splitting the money between, I don't know, if there's some royalties, if there are some fees, whatever. And please make it easy for me. No, it's in another library. I hate this stuff, but currency transfer lib, it's actually in a library because people love to make it easy. So as you can see, it's going to call this transfer currency with wrapper, and it's going to perform some checks if it's native token or not, but whatever. What you need to check is this thing here, which is the safe transfer ERC20. And what this does is, ignore this case, of course, because this is the easy case when it's the smart contract actually sending tokens. But in this case, as you can see, it's calling the safe transfer from. So, and the from, it's the user that it's paying, and the to is the user that it's selling. So basically acts as a middleware in this case. So if we go back to this stuff, and we add a third actor here, and this is the seller. Let's change this to buyer. Let's make this white again, please. So what happens is that the NFT marketplace is going to pull tokens from me, and then it's going to send them to the seller, basically. So these are...
So transfer from does the pool and then...
Yeah, because using the approval that I've done before, I allow the NFT marketplace contract to basically transfer them however it wants. Then, of course, it's up to the smart contract to not steal funds from me, obviously. So that's why smart contracts always need to be verified, they need to be open source, and so on and so forth. But the logic is that I give him the approval, and then I buy. And when I buy the NFT marketplace smart contract, pulls the tokens from me, and it sends them to the buyer. There's no other way where I could have done this stuff. And as I said, it's really complicated, it's ugly, it's disgusting if you want. And it's a pain, and but it's something that we need to live up with. And I don't know for how much time. So we can start the break right now, and we will get back at around 4, I think, 4 something. Thank you. We finished with the ERC20 and the ERC 721 standards. So the next step that we need to do is to start building using scaffolding and starting the speedrun Ethereum, which, as I was mentioning at the start of the lesson, it's a series of challenges that you need to do, and of course we do not have the time to do all of them, but I will send you the link and we will start seeing from the first one, and then we will go forward with them. If I can find the Urbe Campus, it's here. So it's speedrunethereum.com. And the first challenge, and that's why I wanted to talk about the ERC721 and also the ERC20s, is because these tokens are also used inside these challenges, and so you need to know them and how they work before, of course, start challenging the speedrun Ethereum. Also, you need to connect your wallet on speedrun Ethereum, because you will need to submit as well these challenges to the to Beetle Guild, which is basically, as I said yesterday, it's a sponsor of the hackathon, but also it's a community of both very skilled and talented teachers and developers and so on and so forth. And you can learn a lot from that community. So like by doing the speedrun Ethereum and by joining, for example, their Discord, and you will learn a lot about Web3 development. So we can go to the, if you go as well to the first challenge. So this is a really easy, let me zoom in a little bit so that you can read. Hopefully you're following along on your PC as well. So the goal of the first challenge is to, as we saw yesterday, to compile and deploy your first smart contract. So it's basically what we did yesterday, but you can do it alone on your PC today. And you need to follow these instructions, which are the same that we saw yesterday. So it's a different repo in this case, because it comes directly from the challenges and not from the scaffolded repo. But the commands are the same that we saw yesterday: the yarn chain to create the local chain, and then in another window the deployment and the start of the website. And in this challenge, which is not really a challenge, will be just basically navigating what we already saw yesterday. I think it's really cool if you do it on your own and then submit the challenge, so that in the future you can go and do some more stuff. So if you can please execute these commands that you find here and start your first challenge. We will see it together, but I need you to start this one, because otherwise the second one does not make sense and it's more complex. This is the challenge. For one, this is the repo.
If I don't have a yarn,
Because you, okay. Do you have npm or node installed? Do you have?
yeah, I can, yeah.
Okay, to install yarn, you need to execute this command here. So npm install -- global yarn, this one. This will install you yarn if you have an npm. Otherwise, you need to install, of course, node and npm. So this one. You have it? Okay. So.
So you have to do this exercise.
Yeah, we're going to see it together because this one it's really easy. So, well, you can also do it on your own. It's basically you have these checkpoints and it's really easy to follow. But yeah, it's just to make you set up with pretty much everything, and then we will do the challenge one, which is actually a little bit harder than this one. But of course, this one uses some concept of NFTs and stuff, so that's why I wanted to talk a little bit about.
What does in this case
Yarn, it's another package manager like NPM. It's yeah. JavaScript people like to make the same stuff and call it with other names. Yeah, PM, ban, whatever. So, since this one is just a showcase, we can do it together. Then we will go to the second one. So, by following the commands, I will start the chain as we did yesterday from the folder. And as we saw yesterday, these are all the accounts. This is the local network currently running. So it says also in a second terminal we need to, let me open it on VS Code, then we will execute the commands. Yeah, trust, oops. No. What it's called, this stuff? Challenge. So in the second terminal, it says to run the yarn deploy command. So as we saw yesterday, the yarn deploy command is the one that is going to generate the types, and then, well, it's going to deploy the smart contract on the local chain that we are running. As you can see, these are the transactions. And then it's going to create that TypeScript file that I showed you yesterday with all the typings and so on, that it's really useful when using scaffolded. So after deploying, we just need to run the yarn start command, and when it finishes building everything, let me close a little bit of stuff which is not useful anymore. So when it finishes building, as you can see, this looks pretty much the same as yesterday, but also a little bit different. That's why I was telling you yesterday about the fact that with scaffolded, it's not only a way to debug smart contract, but also a really useful base for your first front end, because you have already all the hooks, all the components, a lot of functionality which is already made. So it looks a little bit different, but it's pretty much the same good old speedrun Ethereum. So as we did yesterday, the first step in this case is the one to get some funds from the faucet, which is really easy. Just clicking this button and we will start getting some ETH as well. Get some ETH. I don't know how much is needed, but you can get pretty much as you want. And I think that this one is using my address here. As it says, don't do it like me. So first of all, disconnect. I didn't read the second step. So if you're already connected using MetaMask, disconnect. And in this case, if you're not connected, Scaffolded is going to provide you with something which is called a burner wallet. A burner wallet is basically a temporary wallet that only lives in this current session. So in this case, if I open an incognito window, as you can see, this is a different address from the one that I have over here. So it's basically a temporary / disposable address, you may say. And they are completely different. They live on their own, and it's a useful concept to start developing, and without the need of also needing to handle for the connection, and also without needing to have MetaMask at all. But yeah, so we're going to use the burner wallet as they say. whatever. This is to send tokens. We do not need it right now. So the second checkpoint, sorry, is going to my NFTs page, and of course there's no NFT right now, so we're going to mint one.
Sorry, one moment.
Yeah.
But about the size zero, when you are what checkpoint now?
Checkpoint to this minting,
Okay.
the minting NFTs.
I'm at the checkpoint one, and we can.
Yeah. You can go. You can.
Or we must be with you.
No. Let's follow with me because it's really simple. This is just a showcase of what you can do. There's not really any kind of code to be executed right now. Just wanted to show you the first challenge, and then we will go to the challenge. Like this is the challenge 0. In the challenge 1, we're going to develop some code, and you will actually need to develop some code. So now, now you can follow along with me. If you want to do it on your own, it's easy, so you can also ignore me and do it on your own. I'm just explaining it, and then we will go to the more complex one. So I just want to basically show you how this challenge works, which is not really a challenge. It's just a showcase of what you can do. So you have this mint button over here, where basically you can click it as many times as you want. It's going to decrease your balance of a little bit due to the sending of the transaction, and it's going to mint some animals. As you can see, it's actually uploading data to EPFS, which we already mentioned before. So this is really cool. And you can also, since this code is open source, and maybe at the hackathon you want to see how to interact with EPFS using Scaffold ETH, you can check this repo. That's why I wanted to show you. So we minted these 3 amazing NFTs, and let's open another incognito window. So we have another burner wallet, the one that I just closed because I'm an idiot. So in our incognito window, we have no NFTs, and what it's asking us to do, it's basically transferring this, well, actually minting from here, but also we can transfer directly from the first one to the second one. We can just copy the address, and then we can just basically send this NFT, and without even needing to refresh or anything, we get the Buffalo NFT over here, and you can do the same with the zebra. So Scaffold ETH seems really easy, but at the same time, it's really powerful. So by going on the debug contracts, which is the default page of Scaffold ETH, that it's available on any new instance basically of Scaffold ETH, we can see all the various functions of the ERC721, which is what we were seeing today before. So we have the counter, the name of the NFT, the symbol, total supply, and so on. And if we try and call the token URI, what we get, it's an EPFS URL containing the metadata of the token. In this case, we can just put 1 and get the token URI of the first NFT. And this is actually the metadata of the NFT that we minted. So it was the bison, and which is the famous bison of Scaffold ETH. It's actually their mascot, I think. And these are the traits, the name, the external URL, and the image. This guy is actually the founder of Beetle Guild, which is a pretty nice guy. I don't know. Will Austin Griffith be in Rome, Lemon? Austin Griffith is coming or not? Okay, sadly. Last year he wasn't there, no. It was just Kevin, okay. So, yeah, this is also something that we saw yesterday. So this is basically the deployment of the smart contract, but we do not need to do this stuff right now. So because I want you to start actually coding something useful. So let's jump straight to the challenge one, and this is something that you will need to start doing on your own, and you can ask me questions, and if something is not clear, we will read it together, understand what they're actually trying to do. So I sent you the link over here. This bot can also shut up for a second. And so the first challenge is about a decentralized staking app. So a superpower of Ethereum is allowing you, the builder, to create a simple set of rules that an adversarial group of players can use to work together. Blah, blah, blah. You can create a decentralized application where users can coordinate a group funding effort. So the goal is to build a staker.sol contract that collects ETH from numerous addresses using a payable stake function and keeps track of the balances. After some deadline, if it has at least some threshold of ETH, it sends to an example external contract, which I don't know if you saw the smart contract calls, but we can do it together, and triggers the complete action sending the full balance. If not enough ETH is collected, it allows the users to withdraw. So basically the smart contract, what it's asking is that different users can basically send ETH to the smart contract using a stake function, using a payable stake function. And our smart contract needs to track the balances of each user that it's going to deposit. After some deadline, which if it's written like this, it means that it's going to be a variable of the smart contract. If it has at least some threshold of ETH, so if we reached an amount of ETH inside this smart contract, it's going to send this amount to an external smart contract, and it's going to trigger the complete action. I think that there's this code, it's available over here, so we will also see together the code that it's already available, and then you can start. Instead, if we did not reach enough ETH inside the smart contract, the users can withdraw basically what they staked before. Regarding the front end, what we are asked to do is basically display the information connected inside the smart contract, and the goal is to basically start calling this function. So the front end may be a little bit harder, but we can work. You can work on the Solidity stuff, and then we can do the front end part together. And yeah, blah blah blah. The final deliverable is going to be something built, but whatever. So we can get this. We can get this code. We can get the repo, so we see what's available for you and where you can start. Please execute as well this command, so you start also seeing the repo and the code yourself. So as we saw yesterday, this is the typical scaffold ETH package. You have the RDAT stuff, which is where the smart contract is, where the smart contracts lives and you are going to develop, and then we have the app. So at the start, we need to focus first on the smart contract. Here we have the staker smart contract that you need to implement. Here you have all the various questions, and also the various functions that you need to implement, and this is the logic of this example external contract. So you can start working on solving this stuff, and if you have any questions while you do it, you can ask me. And if you don't think that you can do it, we can do it together. So just let me know if you think that it's too hard or it's not clear, we can do it together. Remember that you also have the checkpoints and useful info on the speedrun Ethereum page, so you can also like follow it along and understand what you're doing if you do not want to do it from scratch. Just to be clear that remember also that if you need to test something or debug your code, you can directly use scaffold ETH. So remember the commands, the yarn chain, the yarn deploy, and the yarn start. So when you start actually adding the functions, you can test them directly on scaffold ETH.
Because yesterday I wasn't there.
Yeah.
I don't really understand what this scaffold at.
So basically scaffold ETH is a starter for, it's mainly for debugging smart contracts, but in reality it can be used also as a starter for front ends that interact with smart contracts. So when you use it in a plain way, you have this functionality that is shown over here in this image, which is the debug contracts, where basically you can call your smart contracts, you can read the various parameters like you would do in Remix. The fact that it's better than Remix because you can actually edit it with code. Deployment of the smart contract, it's easier. You just need to run a single command on your terminal and so on. So you need to imagine it right now by following, as I said, there's the checkpoints and what you need to do, except from the actual implementation. But there's some checkpoints of what you need to do, and they guide you alongside this challenge, basically. So that's what it's basically scaffold ETH. Some sort of a starter, you may say.
So you can start the project in the hackathon, for example, with scaffold.
Yeah. Yeah. I think that there's a bounty as well for people using scaffold ETH. So.
Right on the top line, it says where it says the Plasma Solidity version is fixed on 0.8.4, and for me, it right now makes I did the whole normal install like everything, but there it says I have locally 0.827, so it's not the same.
if you have this, you can change it. Like ignore these negatively impact submission grading. You can ignore it. If you have another version, you can put your version.
I was thinking to change that version, but better not, you would say.
No. You can. There's no need to not change it.
I mean, change the version of the compiler, I thought that maybe it's unnecessary, or it's not a good idea.
If it gives you problem, like if you cannot install the 0.8.4, you can also use the current one that you have without any problem. It should work. So it's just that they want to keep it for them when you submit this stuff. It's better, of course, to have their same version, but
Obviously, forget the Sepolia on my address. I need to go to the link of the vouchers at step 3.
when you're doing it on Sepolia, not on Ardat, yeah, you need actually the Sepolia ETH. But you can, if you are doing like you are deploying it on Sepolia already.
No, I'm at the checkpoint 3 and there.
Of the challenge 1 or the challenge 0?
The 0.
No, you need to be at the challenge 1. We are looking at the challenge 1 right now. That's why. I don't know. Are you all still at checkpoint 1? Someone else? Okay, so maybe we can start seeing it together, so we can go a little bit faster. So So let's follow the checkpoint one. So it's going to tell us that, as we said in the start, we need to track the individual balances and also to manage the threshold. So it's conveniently saying to us how we need to define, in this case, the balances and the current threshold. The threshold, as we were reading before, is the amount of ETH that we need to receive in order to be able to call the external smart contract. So, of course, it does not say how we need to develop this function. It just tells us that we can write it and test it, basically. So, we need to type the stake function, which is going to be public. And so, before writing the stake function, is also telling us that we need to add the stake event as well, which is an event that the stake function needs to emit, basically. So we're going to define the stake event as we can call it staker and amount. So I won't type anything because you will get spoilers from the compiler, from the GitHub compiler, but the idea is that the stake function, what it needs to do, it needs to increment the amount of ETH that I've staked inside the smart contract by updating my balance, and then it needs to emit the stake event. So I would just say the balances of the message.sender is going to increase by the value, which was something that we were seeing before. And then we just need to emit the stake with the message.sender and the message.value. So this is basically the easiest way to implement this stake function. And as we read also here at the end, we need also to add the receive special function that allows the smart contract to receive ETH and it's going to call stake. So we just type receive payable. Does this need to be a function? No. This should be calling stake. It should be payable. This should be external payable. So basically, this is the simplest and the most functional way to implement the staking in the context of our smart contract. So we can remove this comment because we did this, and also we can remove this comment as well because we did this. So to recap real fast, we added the mapping, we set the threshold to be 1 ETH, we created the stake event. The stake function, what it does, it basically receives increases my balance inside the mapping by the message value, and then emits a stake event. I will leave it like, okay. So what it's telling us right now is that we need to test it, basically. So as we did before, and as we projects Urbe challenge 1, we are going to do the same yarn chain as before. So we start the local chain, then we are going to deploy using the yarn deploy. This should be deploying the staker smart contract, yes. And then we start our amazing scaffold ETH. So we're going to test our staking function to see if it works. So decentralized staking app, blah, blah, blah. We have our burner wallet. I'm going to get some funds from the faucet, and it tells us to basically, do you see the staker contract, the balance of the staker contract go up when you call stake? So we go into the debug contract and we click on staker here. So we have our staker contract. We need to pass, let's get some money, Ethereum unit converters, this is, I don't know if there's one over here. Ah, okay, I can multiply it from here. So this is really cool. So this is what I was saying about the decimals. Here I can click multiply by 10 to the power of 18, and this gives me 1/8. So we are going to check the first question. Do we see the balance of the staker contract go up when you stake? It does. It does not. Yes. It has become 1, and mine has decreased. So I paid 1 plus the transaction fee. So it worked. The second question is my balance correctly tracked? So we copy our address, we put it inside the balances. If I click on read, I've actually deposited 1/8. So it seems that our function is working pretty fine. And the third question is, do you see the events in the stake events tab? So if I go on the stake events, I can see that there's one stake event which is mine, because I've only staked one time the ETH. So I can stake it another time, and we should see the balance go to 2. And the same as before, we can put it here. I stake 2 ETH, and there are 2 stake events. So I think that we passed pretty easily the first checkpoint. So simple function that updates a mapping and emits an event. This is the receive, which is needed to, of course, receive ETH, otherwise this would not work. And yeah, I will keep it, let's move this here so everything gets close. So this is the contract. So let's go to the second checkpoint, which is a little bit more complicated. Oh, yeah.
Pressing stake, it doesn't work. You have to deploy it another time before, after writing the code.
What do you mean? Like, did you do the yarn chain and yarn deploy?
Yeah. But after I wrote on the staker file.
Did you add also the receive function? Like,
Yeah. No. Yeah.
do you have it like this, and it's not working?
No. Maybe I have to deploy it again? I don't know. This is what I
Did
got.
you?
I got stake
Because stake
here
functions.
and receive down here.
Need to put this one public as well. Can you try and redeploy it? You can type yarn deploy in the terminal. Oh, you have a typo on the.
Okay.
Yeah.
Nothing too fancy.
I'm just worried about the version.
Yeah, I said that, but it worked before.
As expected 0.
Example.
Yeah, this you need to leave it. You cannot remove the. Oh, and add the other bracket. It's missing one bracket. Manca la parentesi. Qua sotto. Alla fine del constructor ti manca. Vai, riprova adesso.
Abbiamo installato l'ultima.
Sì, ma infatti non c'è problema la versione su editor, dovrebbe andare. Yeah?
The UI, it shows the amount, but when I go into the buckets, it's zero. I'm just wondering.
No, you need to go on staker. That's the other contract. No worries. No worries. So you can try it. Whenever you're ready, just let me know, and we will go to the second checkpoint, which is a little bit more complicated. Okay. Let's go to the second checkpoint. So the second checkpoint is thinking about our smart contract like a state machine. So what does it mean? Is that when we deploy the smart contract, there's the stake period. So it's the period where the addresses can actually send ETH to our smart contract. And then in the case of reaching the threshold, we have a success state. Otherwise, we go into the withdraw state. So that's basically the logic of our smart contract. And so it's telling us to set this deadline variable over here equal to the block.timestamp plus 30 seconds. What does that mean? So block.timestamp, when it's used inside a function, when it's used outside of a function, it's equal to the timestamp of the block in which this smart contract was deployed. And plus 30 seconds is plus 30 seconds. So basically, when we deploy this smart contract, the deadline, it's equal to 30 seconds after we deploy the smart contract. So if we would deploy it like this, users would have only 30 seconds to basically stake their tokens, like their ETH, inside the contract. And let's leave it like this for keeping up with the checkpoint. So as it says, of course, and as hopefully Fabrizio told you, smart contracts cannot, even if a lot of people may be telling, no, you can execute things automatically with smart contracts. Sadly, that's not the truth. There's nothing even remotely closer to automation inside of the whole blockchain logic. Of course, outside there are some systems that you can implement, but nothing is automatic. So we need to have an execute function. We need to add an execute function that anyone can call. So it's going to be a public. There's not going to be any check, and this needs to be called just once after the deadline has expired. So only once when we are over the deadline. So let's create the execute function, which is going to be execute. It's not going to take any parameter, and it's going to be public as well. So the execute function needs to, as specification, needs to be called just once and just only after the deadline has expired. So we need to have the deadline, the current block.timestamp needs to be after the deadline. So when we call this function, we need to perform this check. So only after the deadline we can go on with the logic of the execute function. So let's add this deadline not reached. And then it's telling us, so if the address of the contract is over the threshold by the deadline, we want to call the external smart contract. So it's really easy to call a smart contract. As you can see, it seems complicated, but it's not. So what we need to do is, so if the address of this, it's a way to reference the current smart contract, dot balance is greater or equal than the threshold, we need to copy and paste this stuff. So this what it does is going to call the complete function, which is available on the other smart contract over here. It's going to call the complete function and is going to send the whole balance, basically. So it's a simple check. We check if we basically received enough ETH inside our contract, and someone is calling the execute function and we are after the deadline, we can call the example external contract. Instead, if this is not the case, we need to go back to the logic of if the threshold was not met, which is written over here below, allow everyone to call a withdraw function to withdraw their balance. How can we do this? The easiest way to do this is to have another variable which is going to be a public variable and a Boolean one, and we can call it open to withdraw. Let me know. Yeah, open for withdraw, sorry. It's called open for withdraw. So you do not need to specify a default value because the default value for Booleans in Solidity is false. So you could leave it like this. There's nothing wrong in typing this, but it's a waste of 6 characters. So the easiest way is to have this other variable, which is called open for withdraw. And so then if we did not match the threshold, we need to set the open for withdraw to true. The problem, I'm going to ask you a question. Is this function executable only once? By definition here, the execute function needs to be called only once after the deadline has expired. Is this function executable only once? Can I, after I call it the first time, can I call it again?
Yeah. It depends if the deadline.
No. The answer is yes. I can keep calling it because there's no check that I've already called it, basically. So if we left the implementation of the function like this, what could happen is someone calls the execute, for example, and we do not meet the threshold, and so we set the open for withdraw true. Maybe in the future, maybe in the next block, someone is going to deposit some ETH, and then we meet the threshold, and someone calls again the execute function, but then we are in this bracket of the if statement, and we call the complete. So that's why we need to have this function to be executed only once. And the simpler way to do this is by leveraging the fact that we are setting the open for withdraw variable to true, and we can use this on our advantage to say you can call this execute function only if the open for withdraw was never set, basically. Because in the case was already set, the contract is not open for withdraw. There are other solutions. Another one that is I think even simpler is just to say public executed and then set executed to true and require not executed. So like, as you can see, you can do a lot of different stuff. This is, I think it's a little bit better because in the case you never put it open for withdraw, it would still be callable. So I think it's better to use this executed. I don't know if they suggest something else, but no, yeah. So right now we're going to keep this executed one. So right now what happens is that if has never been executed and we are over the deadline, whatever happens here, so either we call the external smart contract or we open for withdraw, we always mark it as executed, and then we cannot execute it again. So we can delete this. We can redeploy the projects. We can redeploy the contract by calling yarn deploy with the latest changes, and we should see, we should see on debug contracts, on the staker, we should see our execute function. And this is also the deadline. I will try and send a stake. So the stake was received. Let me check this timestamp. This should be 30 seconds from after we deploy the smart contract. So this is just a website, 2 parts, basically timestamps. In our time zone, this timestamp is the 5, 22, and 54 seconds. So should be over right now. So if I try and call the execute function, it says the deadline has not been reached. Maybe it's not completely aligned. Okay, a few seconds ago. Maybe it's my clock that does not work. Block the timestamp needs to be bigger than the deadline. Just let me check 1 second. Ah, okay, yeah, because this one's the... Yeah, let's add this time left function. So we can see actually what's the time left. So the time left function is a view that returns the time left before the deadline, and this is something that we can show on the front end. So let's make this function time left. It's going to be public view returns. As it says over here, if block.timestamp is greater or equal than the deadline, we're going to return 0 because there are 0 seconds left. Otherwise, we're going to return the difference between the deadline and the block.timestamp. This is the time left function. This could also, no, let's not put it. Oh, I'm really curious why this is not. Because this is block based. I get it. Okay, so we staked. As you can see, the time left now is 0, and hopefully deadline not reached. Is that equal the problem? I'm really that stupid? Sorry guys, but there's something that makes no sense. Okay, as you can see now, the time left is 20. We staked once. The time left is 11 seconds. Let me get some more funds. So now it's 2 seconds. Okay, so now it's 0. Okay, so finally it worked. It was there equal because, so we call the execute function. As you can see, the executed was set to true, and the open for withdraw was false because we reached the threshold of over 1 ETH because we deposited more than one ETH. If we go on the example external contract, which is the one that receives the money, as you can see, it has 2 ETH of balance, and completed, of course, is set to true. So we can also take a look at the staker UI if we added everything. So as you can see, they show you the staking app, trigger the example contract, blah blah blah, and this is the UI. And let's see what it's telling us. It tells nothing. Okay, we already did this, which is the receive function. Okay, let's see the goal. Sorry. So we saw the time left counting down whenever we trigger a transaction using the faucet button. That's what we did, and it worked. So if enough ETH is taken by the deadline, does your execute function correctly call complete and stake the ETH? Yes. The last point is, if the threshold isn't met by the deadline, are you able to withdraw your funds? So we're still missing the withdraw point, like the withdraw function. And the withdraw function as the name says, allows us to withdraw withdraw how much we deposited, basically. And so, of course, in order to withdraw, it needs to be open for withdraw, for sure, which is going to be set via the execute. And then it's going to, whatever, this is a check that we can also, yeah, let's put this check as well. This check allows the withdraw function to only be called by someone who has actively staked some tokens, some ETH, sorry. And then we need to basically send the ETH to the user like this. So we get the address payable of the recipient, which in this case is the user that is trying to withdraw its funds. We'll read the amount value from the storage, from the mapping. We set the value to 0 before sending any money, because otherwise this, as we already were saying before, there's the reentrancy attack, and you could call this function basically infinitely. You always need to remember to set this to 0, and then we get back our money really easily. So the last step that we need to test is basically we are going to deploy the smart contract. We are going to trigger multiple blocks using the faucet button, and then we are going to we're going to call the execute function to set the open for withdraw to true, and then we're going to call the withdraw function and in this case get back. Actually, we're going to stake less than 1 ETH so that we can withdraw back. Yeah.
The question in the second line balance message sender, could that be recipient? No, sorry, in the fourth line, yeah.
Yeah.
It's the same, right? It would work. If I write there recipient instead of the message sender in the next line, because I have the recipient. Right?
Yeah, this is just.
It's because it's casted to.
Yeah.
Flag payable would not change anything.
No. It's just it's still an address. Yeah. So we need to, since we added this check, which I think it's useful, which is to require the someone who calls the withdraw to actually have staked any ETH. We are going to stake less than 1 ETH so that we do not need to, so that we can actually call this withdraw function. So we are going to call the deploy. I'm going back to the, I don't know what is this, but let's go to the debug contract. As you can see, I'm going to stake 0.1 ETH. Remember to multiply it. So the balance is less than the threshold. The threshold is 1 ETH, and we send 0.1. So we are still waiting for the time left, so we need to trigger. You need to click on the refresh.
Yeah, for me, if I click it, nothing happens.
That's strange.
Yeah.
Are you clicking on the faucet button? You need to trigger a transaction. If you trigger a transaction and then you click over here, it's going to refresh. So right now, the time left is 0. The balance of this smart contract is 0.1, so it's less than the threshold. I'll try to call the execute, and as you can see, it has been executed, and it's open for withdraw. You can also check if we try to call execute again, it tells us that it's already been executed. And then if we try to call the withdraw function, we should see the balance of the smart contract go to 0, and our balance got back to 11, almost 11. So we also checked up the last point of this checkpoint over here. This, as I said before, we already done in the start. So basically, the cool thing that we did using this receive over here is that if you try and send directly ETH to this contract, you are actually calling the stake function. What does that mean? It's easier to show it in action. Since there's no check on the stake function on when it's called, we can call it pretty much everywhere. So if I go over here, how can wasn't there a way to send tokens from here? Oof, I don't remember how to send tokens. Okay. So if we go over here on the bottom, we click on faucet. We set the address of the user of the contract. Sorry, of the staker contract. If you put 0.1 ETH and we hit send, as you can see, the balance has changed. But what it's really cool is that if we go on the stake events, it looks like the address of the faucet actually staked some money, because in this case we send them the tokens using the faucet, but basically the faucet has sent 0.1 ETH to the smart contract. This has triggered the receive function, and the receive function is called the stake function, and so it looks like the faucet contract has staked basically. So if you go on debug contracts and you put the address of the faucet, you can see that he has staked 0.1 ETH. So these matches. So let's see these side quests, which are, this question is something that I've already answered before. So can execute get called more than once, and is that okay? As I said before, no, because it doesn't make sense with the logic that the smart contract needs to have. Then we have this question: can you stake and withdraw freely after the deadline? Is that okay? Do you think that is okay to stake after the deadline? I would say no. So we need to change how the stake function work, and add the check that the current block.timestamp needs to be before the deadline, because otherwise we will not be able to, for example, if the logic of execution, since the execute function has already been called, if someone was to stake their ETH in the contract after the execute function has been called, that would get a real mess, because the funds basically would get stuck in the contract. Even better, we can, instead of using we can use the block.timestamp, but since we are using the executed function, we could also add the check that we never basically call the execute function. So even if we stake after the deadline, we can still basically get the money back. But let's keep it easier with the block.timestamp. So we can only stake before the deadline. So this makes sense. So then we have, what are other implications of anyone being able to withdraw for someone? Does the withdraw function need to be? No. Oh, I lost it. So what are other implications of anyone being able to withdraw for someone? So in the way that we develop this function, actually you cannot withdraw for someone. So only the message sender could withdraw for themselves. We could implement a logic for allowing people to withdraw for someone else and basically pay for the gas, but I don't think that there's any kind of any kind of implication. So here is saying what I was saying before, of make sure the funds can get trapped on the contract. And so that's why we added basically the stake function, like this check on the stake function, so that people cannot stake after the deadline. The execute function can only be executed one, and the withdraw function only withdraws the balances of the given user. Have you seen modifiers with Fabrizio?
Yeah.
Okay. So now another thing that we can add is to basically create a not completed modifier. And this modifier is going to check that the external contract is not completed. And we are going to use it to protect our execute and withdraw function. So this is really, really easy. We just need to create this new modifier not completed, which is actually just going to call let's make it more readable. Let's say is completed. We are going to call the example contract completed, required to be not completed. And so the cool thing about modifiers is that you can as well call other smart contracts and read data. And of course you could do it also like this, but this is actually more readable. And so we need to use this to protect, as they were saying, the execute and the withdraw function. So right now we have basically secured our smart contract from pretty much everything. So now this wants to deploy the smart contract and so on. So the last step is, instead, I wanted to show you how they are interacting with the smart contract and how they are reading events, because this is something that we didn't see yesterday, but we are going to see today. So if we go instead, we're going to close the r.stuff. So the smart contract is done, it's finished, it works. What we need to see instead is the Staker UI page. The Staker UI page, there's this huge component, but basically what it does is uses the hooks that we were seeing yesterday. So for example, the use scaffold read contract to get the threshold parameter, the time left value, the balances by passing the address of the user, and the is staking completed to check for the completed variable on the example external contract. So basically this page is basically built only using the scaffold ETH hooks. And let's see how they use these hooks and how they use them to basically build this type of page. So this box over here, of course, it's a conditional box, and it's a box that appears only if the staking is completed. So this is how you basically add a condition inside the HTML when you return from a React component. So what it does, it's retrieving the completed property from the example external contract, is mapping it, it's retrieving data, and it's calling it isStakeCompleted. This is shorthand in TypeScript to basically rename a variable when you use this structuring. This is equal to saying basically const data. It's not properly equal, but it's like saying this, but it's without creating a copy. It's just changing the name. So it's really useful. So it's using the isStakeCompleted to basically add conditionality to the page. It shows this really ugly message, and then it uses the ETH to price, which is this really cool component that you can use in your app as well. That basically changes from ETH to $2. The same thing goes, of course, for all the other various parameters over here. For the time left, is it's reading it directly from the contract. It's basically just 3 lines. And what it's really cool about scaffold ETH and their hooks is that, while we saw, I showed you yesterday, I think, a little bit of the WAGMI ones, the scaffold ETH, they extend the WAGMI ones and they actually allow you to pass the watch property as well. The watch property is really cool because it basically, whenever there's a change on that given variable on the smart contract, it's going to change also on your code. So this is really nice to basically perform some really cool interactive pages, and it's also nice to show in a demo as well that your front end actually reacts to the changes that happen in the smart contract. So this page is, all this basically data is read, as I said, and then we have the functions. These are the 3 functions that we just developed. So the execute, the withdraw, and the stake. I'm going to redeploy the smart contract, and I'm going to make a little change. I'm going to change this to, let's change it to 2 minutes so that we have a little bit of time. I close this. If we refresh, as you can see, we have 1 minute and 59 seconds left in this case. We staked 0 ETH, the total stake is 0 over the 1 threshold. If I call the stake 0.5 ETH, the total stake directly, automatically changes. I don't need to do anything. If I click stake again, it changes. So this is the power of the watch functionality, like the watch property basically. Since the example external contract does not get redeployed because it's always the same, because we are not changing it, this message is always available here, but let's ignore it for now. Oh no. Instead, let's do a yarn deploy -- reset, so we do not have that message. So it makes more sense, sorry. So as you can see, right now, there's no more the banner because I've used the -- reset. So basically, I've emptied all the state of the blockchain and recreated from 0. So if I click on stake, I just want to reach the total amount. So we have 1 ETH staked. So we reach the threshold. How are they basically calling the smart contract? They are using the use scaffold write contract hook that gets as a parameter the name of the smart contract that you want to interact with. And this is going to give you this write contract async function. Function. This is the function that we need to call by passing various parameters to interact with the staker smart contract. If we search in the file, you would see that our functions right now are pretty easy because we do not pass basically any parameter except for the stake one. But as you can see, if we have solidity functions without arguments, you just call the write contract async function. You just pass the name of the function that you want to execute on this smart contract, and you are interacting with the blockchain. So it's really easy. And this is actually a dream for someone that, like me, that used to do all this stuff by hand, basically. Right now, you can do an interaction with a smart contract by using one simple line of code. And the same goes with the withdraw function. Instead, the stake 0.5 Ether button, which is this one, calls the stake function and passes as a value 0.5 ETH. Of course, you need to, if you remember what we did yesterday with React and with useState, if you add, for example, here an input field and you store how much ETH the user wants to send, and we will do it right now, we can also make this stake 0.5 Ether I forgetting the word in English, dynamic. So there should be a really nice already made component from scaffolded which is called ether input. Ether input. In this case, the ether input wants a value, a name, a placeholder, an on change, and so on and so forth. So the first step that we need to do is to manage somewhere the state of how much stake the user wants to put. So we're going to call a stake amount, as we did yesterday. Use state. We're going to call it string and point 0.5 in this case. We're going to set the value of the ether input. We're going to link it to the stake amount. We're going to set the onChange function of the ether input. This is the new value that it's coming from their input, and we are going to update the stake amount. And yeah, see whatever you want. And we can change this parts ether over here with the stake amount variable. And we can change also this value over here. So if we go back to the page, as you can see, right now we have this input. If I type 0.15, it changes also the button over here. I can put, I don't know, 151, I can put 1 ETH, and as you can see, it's dynamic. Of course, I can also put 0, but this is just to showcase, basically. So since this is dynamic, now the user can input how much he wants. In this case, I want to stake 1.5 ETH. If I click on stake, in this case, we already reached the deadline because I was too slow, but let's redeploy real fast the contract so we have a fresh one. I hate you when you do this. If I click on stake, as you can see, I'm staking 1.5 ETH every time. I can change this to 1.25 and so on. So basically we are using this ether input field and dynamically changing how much stake basically the user is sending. There are some other really cool components that are basically scattered around all the scaffolded. There's also should be there documentation about the components over here. So what we just used was this ether input, which I don't even think it's the correct one because it's the one that switches from ETH to USD, but maybe this one was the one to use. So the integer input, which is the one that allows us to switch between Ether and Way basically, and backside also. There's the input address, which is the one that we were using before in the challenge 0. We saw it in the challenge 0, but we also should have it here as well. If I type, for example, as you can see, I typed my ENS, which is this is basically my Ethereum username. And what it's really cool is that it already is mapping it to my real address. So this is I can assure you that this one is my address. And this is also really, 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 really cool. Like if you use these components, you will impress, in my opinion, because they are really simple, but at the same time they are really powerful. So the ones that I would suggest you using are the address input, the integer input, and mainly and also the balance, which was the really cool one that switches between ETH and dollars. And yeah, the
How much do you care about the design?
Me personally, as a judge or as a Well, it's not the design that matters the most. Like what matters the most if it works, of course. Like something that is pretty and it doesn't work, it doesn't matter that it's pretty, in my opinion. But of course, the Limone should have showed you before. I was outside doing a call, but we have as judges when we will give votes to your projects, we will have all different categories, and of course, design is one of them, but it should be, and it is, the category with the lowest maximum amount of points that you can score in. So at the end of the day, it's not that important, but of course, if two projects score the same points everywhere, and one is better and more usable than the other, of course it's going to win. But you need to match a lot of different parameters. I will show you later, because there's the last thing that I wanted to show you, which is something really nice as well, is the events. And I'm going to go real fast on this one. It should be stakings, right? Yeah, stakings. The stakings basically to read events from a smart contract using Scaffold ETH, you have two choices. The first one is to use the use Scaffold event history, and the use Scaffold event history, as the name says, basically retrieves all the events from the given block that you pass. In this case, it's 0. Now, this from block 0 works because we are working on a local chain. Do not try to set a value, like set from block to 0 when you will be at the hackathon or when you will be on a testnet, because of course this would mean to start reading a lot of blocks, and so most likely the page will crash, or either the API call will crash, and so on. So the best practice instead is to put the timestamp of the contract deployment over here. So when you deploy the smart contract, you will be able to get the block.timestamp, and you just smash it over there, and so you will only read the events from when the smart contract was deployed. And the other way instead is using the watch contract event instead, which takes the same parameters as the other one, except from the from block, and instead it gets this really nice function which is called onlogs. Yeah, whatever you want. I don't know why this is linter. Okay. And gets this onlogs function that basically this hook over here is going to trigger every time an event, anytime the stake event is being emitted by the staker contract. So this is useful for doing some real-time stuff in your application. Maybe, I don't know, you are creating this, let's get back to the NFT marketplace stuff. You are creating this NFT marketplace, and whenever a user purchases an NFT, you want to update the page, you want to update the user profile maybe. So what do is you use the use Scaffold watch contract event, so in real time you can catch that log and update, for example, the user profile, or I don't know, change the amount of item he owns in his inventory, I don't know, inside of a game, whatever you want to do. So this is used for real-time stuff, while instead the event history, it's just the past history. So this one does not react to new events, while this one is the one that it's always active and always reads for events. And to answer your question before, this is something that I would like to show, because we are one of the few hackathons that does this. And here you have, these are all the various parameters, how much, like what are the questions that I and the other judges will be answering, and how much point is going to score. And like the ETHRome hackathon, as Limone said before, we are developers, and so it's just a matter of numbers. So what comes out from this is who's gonna win. So there's nothing more, nothing less of basically a score. And it's public. You have it under judging. This is the judging criteria. Total amount is 100, and it's really hard to get 100. I think the guy over there, Matthias, was the highest scorer last year with 74, I think. So it's pretty hard to score 100, but yeah, as you can see, we do not have anything related to design at all. So you don't need to worry about the design.
Do you judge code quality? I mean, it's always hard to ignore, right, when you look at code.
So the code quality, like code quality in the sense of how well is the code written? No. How beautiful it is? Yeah. No. Sadly not, but just for timing reasons.
I would say so. Exactly. For prototyping,
Yeah. What we check instead is after the hackathon, what we do is that we look into the code repos and we check for example, if the code, if you started developing weeks before the hackathon, or if you stole code from somewhere, maybe from other hackathon projects and stuff like that. As you can see, there's this note. We have a 7-day period to actually change the results of the tracks. Whatever the sponsors do, it's just up to them. We don't care about the sponsors and the bounties, but for us, we really take great care of the track, so we always check for irregularities and stuff, and so we check if someone has cheated, basically. So even
how do you check if somebody has prepared the code?
well, there are some ways and some stuff. So, for example, something that I do not like that I see in a GitHub repo is if magically, when I don't know, there are 3 hours missing to the hackathon, there's no commit, and then pam, you see all the application coming. That's a red flag in my opinion, because I don't know how you built it, when you built it, if maybe it's something that you've been building for the last days. The best way, and it should be written somewhere over here, because we explain pretty much everything, but it should be one. Yeah, you need to commit, like you need to commit by commit. You need to prove that you are actively working on it, and that you worked on it on the hackathon. We allow external projects that started outside of the hackathon, but the only thing that it will be judged, the only thing that it will be submitted, and it's going to be what has been built to the hackathon. So if you are building the newest electrical machine, I don't care. If you did nothing in the hackathon, I don't care about the idea at the start. What's important is what you do at the hackathon. And also, even if we allow them, nobody has ever come to ETHRome with their already existing idea, because it's also hard to prove that you did not work on that kind of stuff before, and so since we are really strict, nobody has ever done it.
So it's not recommended?
No, it's...
You mentioned that if somebody's working in March, it's like, okay, as a side thing, building this thing on top of the app. And
yeah, but there are a lot of hackathons that allow it, but we are kind of against. Like, we are not 100% against it. The problem is that it becomes hard for us judges to understand what you actually built during the hackathon. And if for me it becomes an headache to understand what you built, so it shouldn't be my problem as a judge. You need to be clear, and if you are able to come to the hackathon with your already started idea, you are able to prove me in any way how, like what you built and so on, I'm 100% happy to do it. For example, what me and Limone do at hackathons when we want to work on new features for some projects that we develop, what we do is actually we create a complete new project. So under a new name, something which is, we do it from scratch and it has only the new functionalities. So then when the hackathon is finished, the judges have confirmed, we get the code and we put it back on the original. So because we want to keep it fair. So that's what we suggest every time. So if you want to work on new functionalities, it's better for you to submit a project on new functionalities rather than pushing, like presenting yourself with a repo that's 2 years old. So yeah, that was pretty much it. I'm sorry that it was really hard for me to basically to start from JavaScript basically and to come to until scaffolded in just 2 days. This is something that usually takes a little bit more time, but if you have any question, you will find me as well at the hackathon. I will be there the whole day of Saturday and Sunday as well, and I will be at the check-in tomorrow as well. But of course, during the check-in, I will be giving you tickets. So you can ask me anything again at the hackathon if you have any questions, and so you can bother me. You need to ask the cool hair guy.
2 p.m. Like check-in from 2 p.m. But actually, there's a side event happening tomorrow morning. It's in the same venue, separate room. So we will not be checking in for the hackathon there, but we couldn't be already in the venue. So there also will be lunch if you want to have lunch there. And then after 2 p.m. we will start the overall check-in process.
Thank you so much, guys.